Welcome and hello. This is a video exercise in HEC RAS, and in this exercise, we are going to be dealing with reservoir release using the flow hydrograph optimization feature. In this exercise, I'll use the flow hydrograph optimization feature to determine what is the maximum upstream reservoir release, which will not flood out a downstream location. All right, so what I have on the screen here is my HEC RAS. We're going to start from scratch, and I'm going to start with File, New Project, navigate to the directory that I want to save the project in. Okay, and then for the title, go ahead and give the project a title. All right, and then click OK, and then click OK. First, what I'm going to do is sketch out the geometry file and then save that, and then the flow file, and then run the simulation. So what I'm going to do by starting off is, got to click river reach first, and then single left click on the upstream end of the reach, and then make a few clicks to give the reach some curvature. And then finally a double click at the bottom of the reach. I'm going to name this river Main River, and then the reach, I'll just call it Reach 1. All right, next I'm going to go and click the cross-section button and then define some of the cross-sections. Options, add a new cross-section. This will start at the bottom down here at River Station 0. And then what I have copied out to my clipboard now is the station and elevation data, so I'll paste that in. We'll get a preview of this over here in the side panel in just a moment. All right, this is going to be 0 distance downstream. I'm going to type in the Manning's N values. And then the left and right overbank stations are 100 and 250. All right, and then click Apply Data. So this is the preview over here to the side. Next, I'm going to create an upstream cross-section at the very top of the reach, and that will be 10,000 feet upstream. So the quick way to do that is just go Options, copy the current cross-section. This is going to be River Station 10,000, and then OK. I need to change the distance downstream to the next cross-section as a length of 10,000 feet. And the last thing I want to do is add some elevation. So adjust elevation, and I'm going to add 20. That way the invert change from 30 up to 50. All right, so click Apply Data. Let's go ahead and close out of the cross-section editor. And now we see our two river reaches, our one river reach with the two cross-sections. Next, I'm going to add some intermediate cross-sections. So this is going to be for all river stations. I could also just literally explicitly define the number. And we're going to do every 2,000 feet. So if I click Interpolate and then close, I now have cross-sections that are linear interpolations at 2,000, 4,000, 6,000, and 8,000 feet. Next, what I want to do is create a side channel here. I'm going to call it the east channel. So assuming north is up, east would kind of be on the right side. And it's going to be near River Station 6,000. But the way HEC RAS works is you need to have an upstream and downstream river station for every reach. Every reach needs at least 2 cross sections, and you specifically need cross sections that are close to. Oops, hold on. Let me go. This is not to scale, so I'm just going to add a little bit of distance to each dimension here, and -1. Okay, so if I click OK, it should zoom me out a little bit. Yeah, now we can zoom in a little easier. What I was going to say is I'm going to create a junction right here for my east channel. But before I do that, I'm going to create a river station at 6,200 with the exact same cross section you're seeing here. So I'm going to go back to cross sections, and then we're going to go to 6,000 right there. Okay, options, copy the current cross section. This is going to be 6,200. Okay, so the downstream distance here is just going to be 200. Okay, so apply data. It's going to have the same elevation. So that's fine. And then the next cross section upstream is 8,000. I need to actually change the downstream distance here to 1,800. So the total length of that main river will maintain the distance of 10,000 feet. Okay, apply data. We can go ahead and plot the profile. And you can see it's pretty much a constant slope except for a slight little flat spot right here. And that's fine. Okay, now I've got my river station 6,000 and 6,200. That's good. I'm going to click on river reach, and then I'm going to start the river reach just in the middle here, so around 6,100 more or less, and single left click. And then let's see, I'm just going to do a couple more clicks. I'm going to zoom out by rolling the mouse wheel back a couple times, and you can also recenter the view by clicking the right mouse button. So I'm going to do a left click. I'm going to zoom out by right clicking. Oops, it thought it was a double click. Okay, I messed up. Let's try that again. Okay, river reach. I want to click right on the river there. Okay, and then I'm trying to zoom out. Okay, that's good enough. And then I'll add a few more reaches or vertices, and then a double click here at the end. The line looks kind of messed up, but when you double click, it actually looks like it gets fixed. I'm going to call this river East Channel. So that's reach 1, that's fine. Click OK. Do I wish to split the reach on that main river? And the answer is yes. And now it's asking me, what do I want to name this downstream section? It's still going to be main river, but I'm going to call it reach 2. And I'll click OK. Finally, it's asking me for the name of the junction. I'm just going to call it junction 1. I only have one junction. Okay. So now we have an updated river schematic, and I need to define the station and elevation data of this east channel here that we just drew in. So I'm going to click on the cross-section editor, right? And then make sure I've got the east channel selected. There's only one reach. And then let's start by adding a new cross-section, river station 0. So I'm going to define the cross-section down here first. And what I have on my clipboard is that data. So Control V to paste. That looks good. All right, so again, we're going to have 0 distance downstream. This is the Manning's End. Main channel bank stations on the left is going to be 60, and then on the right will be 180. All right, so I'm going to click Apply Data. Next, I'm going to create one more cross section at the top of the reach, which is actually at the junction, and that'll be at River Station 5000. So I'm just going to copy this one, Options, copy current cross section, 5000, and OK. I need to change that downstream distance to 5,000 as well. Everything else is the same, except I need to add some elevation. So I'm going to add 10 feet, options, adjust elevation, and 10 feet. Okay, so I have an invert of 42 here at the junction through the east channel. Let me go ahead and apply that. And then if I go to my main river, and then let's go down to 6,200. The invert is also 42. Okay, good. So that should be fine. There are some properties about the junction too. So for instance, if I click on the junction, edit junction, if I have any problems with stability, then I may use this energy balance method. But the default is to force the equal water surface elevations. And I think that'll be fine based on how I've set up the geometry. All right, so we may need to return to that, but probably not. The last thing I want to do here is to add some intermediate cross sections to our east channel. So let's go ahead and click on Tools, Cross Section within a reach, east channel, yep, for all river stations. And this is going to be every 1,000 feet. I'll click Interpolate and then Close. All right, it's time to save the geometry file. I'm going to come up to File, Save Geometry Data. And then for the title, I'm going to call this No Pump. You're going to see why later on in the exercise, but there's no pumps. And click OK. Now it's time to define the flow data. So to do that, I'm going to come up to Edit and then Unsteady Flow Data. For the downstream boundary conditions, which are the two here at River Station 0 and River Station 0, I'm going to simply just assign it to normal depth and then use 0.2%. So nothing too exciting there. Okay. And then for the upstream part of the reach, at the top of the reach here, this is going to represent our reservoir. Now, I'm not going to draw in a reservoir. HEC Res Sim has a reservoir element, obviously. HMS has a reservoir element, but HEC RAS doesn't have a dedicated reservoir element. You could obviously use an inline structure to represent a reservoir. I'm just going to pretend this upstream cross-section at 10,000 is the reservoir, and the flow hydrograph I'm defining right now in the unsteady flow data editor is the release from that reservoir. So just keep that in mind. All right, so let's go ahead and define that as a flow hydrograph. I'm going to use the simulation time at a 1 hour time step. And what I want to do is just increase the flow from 1,000 up to 10,000. So I'm going to start it at 1,000. And then I'm going to just sit at 1,000 for a while. 2, 3, 4, 5, 6, 7, 8, 9, 10. Then I'm going to type 10,000 in at 10 hours later. And I think that should work if I click the interpolate missing values. Yes, so we have 1,000 and then it ramps up to 10,000. This is going to be a 3-day simulation. I just typically use that as my sort of my default simulation duration. So I'm going to come down here to hour 73 or 72, or just to be safe, 74. Type in 10,000 and then I can click interpolate missing values here. And then boom, it just fills in all the values for the rest of the simulation. So if I click plot data, what you're seeing here is a start at 1000 CFS, increases up to 10,000, and then just stays there. I'm going to change this a little bit because I want it to not rise so quickly. 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so these should all be deleted. I'm using the interpolate tool again, so it rises 500 CFS per hour instead of 1000 CFS per hour. Interpolate missing values. Okay, I miscounted. So delete all those. Yeah, I think this should work. Interpolate missing values. There we go. So we're increasing at 500 CFS per hour. Now it's a little bit more gradual on that increase. Okay, sounds good. Let me go ahead and save this. So I'll click OK. For the unsteady flow data, I'm going to File, Save Unsteady Flow Data. For the title, I'm just going to call it 1K-10K to sort of represent the flow rate and as it ramps up between the two limits there. And OK. All right, the next thing to do is create the plan and then run the simulation. So I'm going to go to Run Unsteady Flow Analysis. Now, what I'm going to do here is just run the steady state analysis, not the optimization. So we're going to see how the water surface behaves downstream. Right now, I mentioned that the reservoir is at the upstream end of the geometry. So let me back up here. We have the main channel here down the left, and then we have the east channel, which is what I'm calling this east branch. And the water surface elevation that we're interested in is down here at river station 0 of the east channel. So if I zoom in on this cross section here, let's go ahead and take a look at the geometry. East channel. And then if I go down to river station 0, we have a overbank of 41 feet. So what I'm going to do for this problem statement in this exercise is say that the water cannot go over 41 feet at this river station. So we'll see what happens with the initial flow file from 1000 up to 10,000 CFS. And then we're going to use the optimization tool to fine tune it and decide what is the maximum flow rate. It may be more or less than 10,000, but we're going to find out. All right, so back to the run unsteady flow analysis. Let me move the diagram over to the side so it looks good for the video. All right, so let's go ahead and name this plan, save plan. For the title, I'm going to call it base dash no pump. So we have a geometry file with no pump, and base represents we're not using the optimization. This is just the base trial run. And I'll click OK. And then same thing here for the short ID. All right, let me go ahead and turn on the programs to run. And then this is a 3-day simulation, so I can just type in any 3 days because the flow file run starts at the beginning of the simulation. So that's a nice little convenience feature. I'm going to just use the first 3 days of the year 2020. And then for the computation settings, I'm actually going to change this down to 15 minutes for the hydrograph output data, as well as the detailed output data. And then we'll just leave 1 minute here for the computation interval. All right, File, Save Plan, and Compute. Okay, so that looks successful. I'm going to close that. Let's go ahead and take a look at some values here for our results. Cross section. Okay, interesting. So what I'm most curious about is this cross section down here at the downstream end of the east channel. East channel, reach 1, river station 0. Perfect, already there. It looks like the max water surface is just below 41, but more than 40. Let me run the simulation here, or the animation. All right, so the water surface increases as the flow increases. And then, yep, right there. So this represents the peak flow, which is 10,000 CFS. Let's go ahead and check out what that water surface elevation looks like in numbers. So profile summary table. This is the east channel, it says, reach 1. This is the first time step. So the water surface elevation starts down at here at 34.64. That's not what I'm interested in. I can go ahead and turn on the profile that represents a max water surface or all the water surfaces. Let's go ahead and turn all of them on first. So I'll just select all, click, and let me turn off max. Click OK. Now this is a 15-minute time interval, so I got to scroll down here to my river station 0, which is starting here. And you can see as the flow rate increases, so does the water surface elevation. So if we scroll down far enough, we'll see the water surface elevation hit a constant value and hit equilibrium. All right, so here it is, 40.4. I'm going to scroll up just a little bit. Yeah, so it begins right about here is when equilibrium is hit. The flow rate is 4,531 CFS. Now remember, we have 10,000 CFS coming down from the the reservoir, that's how much is released, but then most of it goes down this main channel. But I mean, 45% of it goes through the east channel. So a good amount of it still gets diverted to the east channel and causes a water surface elevation of 40.4. Okay, so next we're going to use the optimization tool to see just how much flow we can put through this east channel, or more directly, how much we can release from the reservoir at the upstream end, just so this water surface elevation is right at 41, or maybe just a little bit below to be safe. So to do that, I'm going to go ahead and close this. I'm going to click on Run, and then I already have the unsteady flow analysis box right here open up. What I'm going to do is save a new plan, and instead of base no pump, it's going to be call it optimized. So I'm going to go File, Save Plan As, and instead of base, optimized, and then click OK. Same thing with the short ID and OK. What I'm going to do here for the optimized plan is click on Options and then Automated Flow Optimization. This is the focus of the exercise, is this dialog box here that was just a lot of other setup required. What we're going to do here is now set the stage. So if you're setting the stage, you need to specify a reference point. If you're specifying the flow, you need to specify a reference location, or I'm sorry, a reference line. Your location will be a line for flow, and your location will be a point for stage. All right, let's go ahead and place a point on the map because we don't have any to select from. And then we'll come back to this dialog, specify that location as well as all the other parameter values. So I'm going to click OK for now, then File, Save Plan, close that. I'm going to come over here to the geometry, still using no pump. That's fine. I'm going to zoom in down here on the cross section. Now, as you can see, we have the entire cross section, and it's hard to see, but we do have the red lines, the red dots representing the overbank. So it would slope down, then we'd have the invert at the base of the channel, and then it would slope back up to that overbank. Actually, this is left overbank and right overbank if you're facing downstream. But anyway, what I want to point out is this reference point button right here. I'm going to go ahead and click on that, and then I'm going to add a reference point just right on the center line. Now it's asking for a name, so I'm going to just call it East Channel River Station 0. Yes, it is a little bit upstream of River Station 0. I get that. I'm just going to call it River Station 0 and then click OK. If I wanted to specify a flow, I would select reference lines right here and then drag a line across and then call it something like East Channel River Station 0, but it would be classified as a reference line. But this is reference point because we're interested in the stage. That's what we want to specify right there at a limit of 41 feet. So let's go back to our plan now. And then let's see. Okay, so we already have optimized and no pump set up. That's good. So options and then automated flow optimization. Okay. Here is the stage, and now we have reference point, East Channel River Station 0 to select. All right, next up is the data we need to provide, this automated flow ratio optimization. The target value is going to be 41. However, the tolerance right here of 0.1 means that 41.1 would actually be an acceptable value, and that's not the case here. What I'm going to do is change the tolerance from a 1/10 of a foot down to a 20th of a foot, 0.05 feet, and then the target value I'm going to set at 39.95. Okay, so what that means is this algorithm will stop and be considered successful if that water surface elevation is within the tolerance of the target, i.e. between 39.90 and between 40.0. All right, the initial flow ratio, let's see here. We'll just put it at 1. The final flow ratio we know is going to be a little bit larger than 1. And what that means is it's going to multiply the current flow data by a certain factor. And it's going to start at 1, and then it's going to search for the correct value. The minimum flow value, we know final value is going to be greater than 1, but I'm just going to set it to 0.9. The maximum flow, I'm just going to set this to 2. This is the flow ratio, because I know it's not going to be twice as much. So it's going to start at 1. It's probably going to end up being 1.1 something. That's just my guess. But definitely between 0.9 and 2. And then I'll just go with the 10 trials as a maximum. I'm going to assume all the other data is correct just right down here, and then click OK, and then File, and then Save Plan. We now have this note down here that says Automated Flow Ratio Optimization. So what it's going to do here is it's going to take the data that we've already put in here, this target data, and it's going to modify the ratio of that inflow data, because they said all hydrographs. We only have one hydrograph, and it's going to hopefully find the reservoir release resulting in a target stage down here at my reference point, close to 41. Oh, I'm sorry, 41. I said 49, so 40.95, and yeah, so it's 41. I was off by an entire foot. We want it to be close to 41. All right, glad I caught that. Okay, and file, save, and compute. All right, so we see the optimization trial 1, trial 2, trial 3, trial 4. Okay, it looks like it was successful. I'm going to scroll up a little bit here. So the first trial, the ratio was 1, so it just tried the same thing as before. 40.41 was about half a foot less than 40.95. So it increased the ratio, increased it again, and then decreased it. Looks like 1138 is the correct ratio. And that's a ratio of 10,000 CFS, which means we could just multiply it. It'd be 11,380. So keep that number in mind, 11,380. The final value, our stage of that location, is 40.95. Okay, let's go ahead and look at the results just to confirm. By the way, if you close that box and you want to go back to see the runtime messages, it's just Options menu, View Runtime Messages, and then you can reread that data. All right, so let me go ahead and look at some results. View cross sections. Okay, this is really close here. East channel, yes, this is the one we want. Let's go ahead and run the animation now. Play. So the water is increasing as we approach our target flow out of the reservoir, and that's very close. Allegedly, it's 40.95, but let's check it out at the table. Summary profile table. Okay, this is at the first time step, so we're not interested in 34.64. That's the water surface at the beginning of the simulation. We're going to click on profiles, and then let's just click on max water surface profile, and then click OK. And sure enough, 40.94. Okay, it should be 40.95, but maybe it rounded down. We'll just go with 40.94. And that came from a flow rate of 5,174.96 CFS, and that's in the east channel. So if I'm curious what the flow rate is upstream in the reservoir release at the very top of our simulation, I can go ahead and check that out. It would be View, Profile Summary Table. And then now for the reaches, that's going to be Main Reach River 1. And then I'll click OK. And then the maximum flow rate here is 11,375.45. So that's probably, we saw 11.38. That's just this number here, rounded to the nearest 10, divided by 10,000. All right, that was fun. Let's go ahead and modify our system one more time, and then just to see how it responds, run the simulation, view the results, and then call it good. So what I'm going to do here, obviously I alluded to it earlier by calling the first geometric data file no pump. I'm going to add a pump and pump some water out of this east channel upstream of the point of interest, our reference point. And because we're removing water from the channel, that will allow us to actually release more water from the reservoir and keep the same control point and the control point characteristics the same. So let's start by, first of all, saving a new geometric file. Save geometry data as, and instead of no pump, I'm just going to call it pump, and then click OK. That way, everything else is saved as. All we have to do is add the pump. So I'm going to click on pump station right here, and then let's go ahead and just put the pump station right here next to river station 4000. I'll say that's where it extracts the water from. I'll call this pump station 1. And then to edit pump station 1, I'll go ahead and click on the edit pump button. The pump connection, this is going to come from river station 4000. So click on RS, and then east channel, yes, reach 1, yes, and then river station 4000. Okay. The pump outlet right here is going to just go out of the system. I don't have a storage area or a 2D flow area or any other reach or node or anywhere else to put it. So I'm just going to say out of the system. However, when you put out of the system, what you also need to specify is the highest elevation. So let's see, 4,000. I'm going to take a quick look at that cross section. Okay, we're already there. So if it's going to pump from maybe 40 is the invert up to 49, and then we'll say 55. So it just pumps over the bank. Okay, so right here, I'm going to type in 55 feet. Next, the pump group data. So here's where we define the pumps, their controls, and then the pump curve. First, the pump curve, I'm going to define the pump curve as such. It's going to have a max flow of 200 CFS. It won't actually be pumping that fast because there is some head involved. All right, so there's the curve. Let me just click the button to make sure it looks correct. There's no typos. That looks good. And then I'm going to add 3 pumps. So they're all going to be called P1, P2, and then P3. And then I'm going to turn the first one on at 45 and off at 42. The next one will turn on at 46 and then off at 43. The last one will turn on at 47 and off at 44. So they're a little bit staggered. I'm not going to use any advanced controls here. I think what we got here will work out just fine. So I'm going to click OK and then again save the geometric file. Now I don't need to run the base case again, but I will because I'm curious about what how these pumps will change things. I'm going to click on Run and then Unsteady Flow Analysis. Now for the geometry file, I have pump, so that looks good. I'm going to go File, Save Plan As. This is going to be called Base Dash Pump. Okay, same thing with the short ID. And then I want to turn off the automated flow optimization because it's base, it's not optimized. I'm just going to turn it off. All the numbers here are preserved, so we won't have to type that in again in just a moment when we run it. And then click OK. So File, Save Plan, and then Run. Okay, that looks fine. I'm going to go ahead and close that. Let's go ahead and take a look at our cross section of interest down here in the east channel. River Station 0, View, Cross Section, and then it's got me at 4,000. So let me change that to River Station 0, Options, Animate, and then Run. So the water's increasing. The first pump turns on. The second pump turns on. The third pump turns on. And then boom, at 10,000 CFS, this is what we have for a water surface elevation. I believe it was 40.4 with no pumps. So with 3 pumps pumping, this is probably going to be lower, closer to 40. Let's go ahead and check out what that number is. So I'm going to go View, Profile Summary Table. And then let's see, I've got the wrong reach here. Let me turn on reach. Main river reach 1. I want east channel reach 1. Okay. And then this is the first time step. So let me just change it to the profile for the max water surface right there. Okay. And it's 39.88. Down here is the bottom cross section at River Station 0. That's what I'm interested in. The max water surface profile with the pumping is now 39.88. Yeah, without pumping, it was 40.4. While we're here, let's just take a quick look at the pumps and what they're up to. So pump, and this is for the pump station. It's not individual pumps, but I can toggle on the profile, and then let's just see every time step. Okay. Keep in mind, this is a 15-minute time step. So there's no pumping until the first day at 8:45. You can see the first pump turns on at the water surface of 45. That's pumping at just under 190 CFS. And then as the head decreases, the flow increases a little bit. And then, of course, it spikes up when the second pump turns on because this is for the entire pump station. You can see the water surface elevation and what it's doing. It dips down for just a couple time steps at a 15-minute time interval. And then it continues to rise. And then finally, here's the third pump that turns on. And if we scroll down long enough, we should see the water surface elevation hit an equilibrium, which looks like it happens right here at 9:15 a.m. And that water surface elevation is 47.78. Now, keep in mind, this is at the cross section, 4,000. So it's not the same thing we're looking at downstream here. But the total pumping is 581 CFS for that pump station, which is all 3 pumps. Since this is the base case, the flow rate at the top of the model here is 10,000 CFS. Ironically, that's the river station as well. But what I want to do now is run the optimization one last time with the pumps on, and then we'll see what that new peak flow or peak release from the reservoir can be. So I'm going to come to Run and then Unsteady Flow. All right. And then I'm going to save a new plan. So Save Plan As, and instead of base here, I'm just going to call this Optimized again, and then click OK. And then for the short ID, call it Optimized. What I need to do now is just toggle on that optimization. So automated flow optimization. Okay, it's turned off, but we can just set that to stage. And then I need to reselect the reference location again. It cleared that out, but that's what I want. And everything else is the same. Again, we're going for a target value of 41 feet, no more, but we have a little bit of tolerance to work with right there. Okay, so okay, file, save plan, and compute. All right, so that completed. And I was watching the blue text fly by. So the first trial is right here. The second trial is right here. We're 48.75, so we need to be a little higher. 41.14, that's too high. And the last one here is 40.95, which is right on target. Probably could have tightened that tolerance up a little bit, even if it cost a few more trials. But yeah, let's go ahead and take a look at the flows and the water surface. So we know that the water surface elevation is 40.95. Let's go ahead and just look at standard table 1 here and then turn on reach. That's good. And then also want to turn on just the HEC water surface profile, which is this first one, and okay. So 40.9, it says 40.94 here. I'll just go with that, 40.94. That's with a flow of 5,178. Okay, what I'm more interested in is the flow upstream at the reservoir, at the release at the very top of the model here. So I should not have closed that. Let me open it up, but this time select a reach. And actually, I can select all the reaches. It shouldn't be too many data points there. That's fine. So here we go. Main river is right here, and the peak flow is 12,506 CFS. You can even see the split in the breakdown here. So we have this 12,506 CFS continues down through the main channel. The east channel gets 5,764 of that, and then the main channel gets 6,742 of that. Of course, this is max water surface profile, so I really should focus in on just a particular time step, but close enough. The answers that we're looking for are right here, 12,506. All right, so just as a quick summary, I've got the 4 different trials here, 1, 2, 3, 4. The first 2 had no pumping. The first one was base, where we had a max reservoir release of 10,000. I made it a nice round number, so it's easy to multiply. And then our water surface elevation started at 40.4. That's at river station 0 of the east channel. When we optimized it, we could release another 1,375 CFS. And when we turned on the pumps, we could release what would result in a total of 12,506. So 2,506 more CFS flow than the base of 10,000 CFS, all with the hard constraint to not exceed a river station stage of 41 at that river station 0 in the east channel.